Solving an exponential equation with exponents on both sides of the equation with two different bases is a little bit more complicated, but very doable. I'm going to show you actually three different ways to do this. The first step is you have to use logs. There's two ways of rewriting this with logs. One of this is to do the same thing to both sides of the equation, which is to take the log of both sides of the equation. You could use a log base 10, which I've done here. You could or a log base 4 or a log base 5 of both sides. But let's just do log base 10 on this side. Another alternative would be to write this in log form. Once again, there's more than one way to do this, but let's say we're using log base 4 of the answer, which is on the other side of the equation, equals the exponent, which is x plus 1. So either way, you could rewrite this using logs. The next step is that since we have some variables in the exponent position that we need to solve for, we need to use the power property and take this out front of the log. So that would be on either side. That's what we would do. So the next step then would to bring that expression out front. It's very important to use parentheses around the expression, or it's going to be easy to make a careless mistake. So make sure to use parentheses. Now the next step, I'm going to do one more step on this side, okay, which is to divide both sides by log of 4. I could have also divided both sides by log of 5. It really doesn't matter. If I divide both sides by log of 4, I want you to realize, using the change of base property, that log base 4 of 5 can be written as log of 5 over log of 4, which is exactly what I have here, log of 5 over log of 4. This fractional expression is equivalent to this, which is equivalent to this. So at this point in the stage, no matter which way you do it, you end up getting to the same point. Now, you can continue through this whole problem leaving that as log 5 and log 4, which are just numbers, and I will show you an alternative version doing that on the next page. But what I would recommend at this point is to find the decimal equivalent for this number, okay, so which I've done on the calculator. So whether you do log base 10 of 5 over log base 10 of 4 or log base 4 of 5, this is the number that you get. So we are going to replace log base 4 of 5 or log base 5, log 5 over log 4 with this decimal number. Most students find this a preferable method because the log bothers them. Logs bother them. So we're just going to change this into a nice decimal number. So now you see this looking like a nice regular old algebraic equation. So the next thing you're going to do is distribute. So I'll go ahead and kind of draw the arrow. So you're going to multiply 1.16096 times x and times 3. Notice that I have written the entire decimal number that I saw in my calculator, also with the dot showing that this is not a terminating decimal. It's a longer decimal. As a matter of fact, if we go back to the calculator and go up and copy and paste this number, you can see that indeed it is a number with a lot more decimal places. So I don't want to round this to just 1.16 or 1.2 or anything like that. I want to leave all the decimal places, because if you round in the intermediate states of the problem, by the time you get to the end, there'll be a lot of error in your answer. So after I've distributed, I get this number. And I'm going to go ahead and do this on the calculator as I go. So I am multiplying this times 3. So notice I'm not I'm not rounding the number as I go. I'm just taking the previous answer times 3. So back and forth. The next step, I'm going to pull this up a little bit. The next step then is to add 3.4898289 to both sides of the equation. So I'm adding this number to 1. So once again, I'll go ahead and do that on my calculator. So plus 1 That's really weird. I have no idea. Wow, that like happened 3 times. Weird. So let me delete some of this. Okay, so there's where I am. Very strange. Okay, and then I am going to subtract x from both sides of the equation. And when I subtract x, realize that's 1x, so that gives me 0.1609x. So on the calculator, I am going to grab that number, minus 1. Okay, so now I have those numbers on my calculator. And notice that I'm not rounding anything. I'm just doing each of these steps on my calculator as I go. And then the last step, of course, would be to divide 4.4829 by 0.1609. So on the calculator, really easy, go up arrow, copy this number, divide, and then up arrow and get this number. And notice now I have not rounded during any of the steps on my calculator. So there is the answer, and we will check the answer now in the original equation. Going back, you want to go back to the very original equation and substitute your answer for x in both of these, on both sides. Now let me show you a really nice way to do this on the calculator. I am going to take my previous number here and I'm going to store it for x. So if you go to Control, Variable, notice the word store up there, and then you're going to go down and put in an x. That means if I type in x, it'll come out as a bold letter and it has this number stored in it. Then I'm going to type in my original equation, and I better go back and check to see what it was. 4 to the x plus 1, 5 to the x plus 3. So 4 to the x plus 1 power, and I'm going to do a Control Enter. That's that value, and 5 to the x plus 3. Do a Control Enter, and oh, that's supposed to be x minus 3. No wonder that you're probably calling half point. That's not what I want. So let me do this again. I'm going to delete this. That's not what I wanted. So 5 to the x minus 3. Okay, notice that we get exactly the same thing. So we've checked the answer and it matches. Now, just to show you one more way to do this problem, as if you needed another way, but just to show you that you can, if you don't want to carry through the decimals like this, you can do the whole thing with logs and not enter in anything into your calculator at the end. So I started out the way I did in the left-hand side on the first version, but now I'm just going to distribute the log to both of these. So I have x times log 4 plus 1 times log 4, x times log 5 minus 3 times log 5. Now I'm going to get anything with an x in it on one side of the equation and anything without an x on it on the other side. So I'm going to subtract x log 4 from both sides of the equation, and I'm going to add 3 log 5 to both sides of the equation. So this side of the equation, the left side, ends up as log 4 plus 3 log 5, and the other side ends up as x log 5 minus x log 4. Then I'm going to factor out the x, and I end up with x times this quantity equal to this quantity. So I now am going to divide both sides by log 4 minus log 5 to get the x by itself. So I end up with log 4 plus 3 log 5 divided by log 5 minus log 4. I enter the whole thing into my equation, into the calculator, and I get the same answer. You could also use some of your log properties and simplify this. I can bring the 3 into the log as an exponent, and then I have a log plus a log, which means I can multiply log 4 times 5 to the third inside the log. I also know log 5 divided by, or log 5 minus log 4 is log of 5 over 4. And so if I enter it into the calculator using log properties, I get exactly the same thing. So there are numerous ways to do this problem, and you may pick the one that you prefer.